You can start by the way, okay? आप इंतजार करते हैं क्या मेरे बोलने का? You can start, okay? Hanifa and Rifat. Please see this last print. Save your PDF as your name and then the date dot PDF, okay? It will be easy for
Okay,
me
sir.
to. Hmm. Hanifa, I forgot yours.
Okay, sir.
Okay.
Can I
Thank
leave?
you. Yeah, you can leave. Okay. Bye.
Thank you, sir.
Ripat, you have 5 more minutes. Okay.
Yes, sir. I'm in the last question.
Okay. Done, Rifat?
Yes, sir. I'm sending.
Okay, great.
I send it, sir.
Rifat, did you prepare for this?
Yes,
Huh?
sir.
Yes.
Yes.
Then how did you leave this question?
Sir, I
You took a-
completely blanked out when that question came.
Sorry, what happened?
I completely blanked out. I couldn't think of anything.
I don't think of anything. Yesterday with this, we did this, no? What I told you guys to have the carbons which are having bromine atoms face each other and just make a bond like this. Do you remember this? No.
Yes.
I
Sir,
remember.
even the give reason second B1.
Acha, you forgot that one also.
Yes.
कराया नहीं है क्या हमने? Alpha saturation, is this the word you are hearing this for the first time?
No,
नहीं
but
ना?
I couldn't give the reason. I couldn't think of a reason.
तो पढ़ा है कि नहीं आपने, ये बताइए. अगर पढ़ा होता तब तो याद होता ना. ये सब रिवाइज नहीं किया था आपने?
हाँ, जब रिवाइज करते वक्त नहीं देखा था अल्फा सैचुरेशन.
नहीं तो रिवाइज करते वक्त देखना था ना. ठीक है, यहाँ पे तो ठीक किया है. एंड ये भी सही है आपका. एंड दिस इज आल्सो फाइन. अच्छा देखिए, हाँ, लिखने के बारे में भी एक बार हम ये बता देते हैं कि जब भी डिफरेंसेस आए ना तो यू ऑलवेज मेक दिस SN1 SN2 और इस तरह से हमेशा डिफरेंस लिखा कीजिए. ओके, व्हाट इट डज इज टीचर को चेक करने में सहूलियत होती है. एंड इफ द टीचर इज आई मीन इफ ही इज कंफर्टेबल चेकिंग योर नोटबुक, then he may give you some extra, or he may be a bit lenient with you. Okay, what I can say. So always think of this कि जब भी जो भी चेक कर रहा है उसको आसानी हो चेक करने में. Okay, that is why you label the, you have written it very perfectly everywhere here, but differences में आप हमेशा याद रखिएगा that you will make a table like this and see it is of 3 marks. ठीक है, so you'll always put at least three points there. Okay, at least 3 points, and make sure that you're not writing the SN1. You don't have it refers to no, you have not written. But some people, they write it like this. In SN1, it refers to nucleophilic substitution reaction unimolecular. It is not a difference. It is just the naming here. है ना? आयशा और अंजुम में क्या फर्क है? उसका नाम आयशा है, इसका नाम अंजुम है. doesn't make sense. Okay, so याद रखिएगा ये सारे points मत लिखिएगा. You always write about the features here. You have written the rate of SN1 increases in the presence of polar protein solvent, whereas SN2 rate decreases in the presence of polar. ठीक है. Reactant has more charge than the transition state wherein SN1. This is not a difference. Intermediate carbocation has more charge. It's not a difference. ये आपको polar protein और aprotic से जो याद आया आपने वही लिख दिया बस. Okay, here I will give you only 1 marks maybe. ठीक है, तो आपने देखा दो पॉइंट आपने रिपीट किया, आपको लग रहा है टीचर नहीं दिखेगा. हाँ, यस रिफत, देखिए हमने कराया तो है SN1 SN2 में. ये देखिए दोनों सवाल साथ ही साथ है. न्यूपेंटालाइन एलाइलिक हैलाइड इज मोर रिएक्टिव, प्रेजेनोइड इज ठीक है, ये तो आपका एलाइलिक वाला हो गया. अल्फा सैचुरेशन आई थिंक इट्स प्री बिफोर दिस. हां, इट इज बिफोर दिस. ये देखिए ये पॉइंट्स दिख रहे हैं आपको,
Yes.
है ना. तो यहाँ पे आपको देखिए इस ये लिखना था पॉइंट. उसके बाद जो फैक्टर्स अफेक्टिंग है ना, ये 3 फैक्टर्स है, राइट. इसमें जो नेचर ऑफ सबस्ट्रेट है, इसमें आपको पता है क्या होता है. SN1 में 3 डिग्री 2 डिग्री 1 डिग्री, SN2 में 1 डिग्री 2 डिग्री 3 डिग्री. ठीक है. दूसरा चीज यहाँ पे आपको ये लिखना था कि कार्बोकेटाइन फॉर्म होता है. ठीक है. और यहाँ पे आपको क्या लिखना था, यहाँ पे कार्बोकेटाइन फॉर्म नहीं होता. यहाँ पे क्या है, द रेट डिपेंड्स ऑन व्हाट, रेट डिपेंड्स ऑन स्टेरिक एंट्रेंस. ठीक है, ये सारे प्रॉपर्टीज हैं. ऐसे एक और डिफरेंस जो है SN और SN2 का, वो हम आखिरी में पढ़ाएंगे तो आपको समझ में आ जाएगा. ठीक है. चलिए लेट अस स्टार्ट टुडेस क्लास. कहाँ तक हुआ था आपका? सेट्स ऑफ रूल हमको पढ़ाना था ना. राइट द टॉपिक सेट्स ऑफ रूल. वैसे जो साइंटिस्ट है, साइंटिस्ट का नाम जेटसेफ है. द रशियन साइंटिस्ट अलेक्जेंडर जेटसेफ. I mean it is written as Zaitsev but pronounced as Zaitsev. Okay. Okay. So Zaitsev rule, what does it say? Zaitsev rule, it is used when we have elimination reactions. Okay. And in elimination reaction, it says that in elimination, what type of product is formed? The product which is having more alkyl groups around the C double bond C. So please write during elimination. During elimination, the hydrogen atom is removed from that beta carbon which has lesser number of hydrogen atom. And gives more substituted alkene as the major product. Simply you can write in one line. Remember what is Zaitsev rule? It says that in elimination, more substituted alkene is preferred. Please let me know when you are done writing. Done? Okay. So I hope you remember this is the same thing that we have done in examples also. Okay, so this is just the rule that we have written now. Application हम लोगों ने पहले ही कर लिया था. Now you write chemical properties of haloarene. Write the topic. Properties of haloarenes. In this you will write the first point. Haloalkanes show nucleophilic substitution but haloarenes show electrophilic substitution. Show electrophilic substitution. What is the reason? The first reason is in haloalkane, the alkyl group, it is not having Rx bond, right? And that is why it is delta positive. This is delta negative. Only nucleophile can attack on this R. Okay, and that is why you will write here in alkyl halides or in haloalkane, the alkyl group is bonded to more electronegative element X. Okay, that is halogen. Due to which positive charge is created in at the carbon atom. Okay, hence nucleophile attacks and haloalkane shows nucleophilic substitution. Right, the next point regarding haloarenes. Okay, now in haloarenes, we know there will be a benzene ring. Okay, and see if the nucleophile comes and it wants to attack, what will happen? It will be repelled, right? So there is a high electron density on the benzene ring, and that is why electrophiles they come and attack here. Okay, so I will write the next point. But in haloarenes, the benzene ring has high electron density, has high electron density. Hence, electrophile attacks and Haloarene shows SE. Electrophilic substitution. Done?
What man?
1 minute. Okay.
Done.
Okay. So, all right now. Electrophilic substitution of haloarenes. Electrophilic substitution of haloarenes. Right here. Haloarenes show the following. Electrophilic substitution reaction. Okay. So first we will look at halogenation. In halogenation, we'll be looking at chlorination. Okay. In halogenation, what will be looking? Chlorination right here. Halogenation. Secondly, it shows nitration. Sulfonation. Now it shows two Friedel-Crafts reaction, Friedel-Crafts acylation and alkylation. Okay, so right, Friedel-Crafts alkylation, Friedel-Crafts acylation. So these are the 5 reactions we'll be looking at. Done.
Yes.
ये reactions याद है आपको रिफत 11th क्लास से? Halogenation, nitration, sulfonation, alkylation, acylation.
I remember them vaguely.
You remember the names at least, right?
Yeah, I remember them.
You remember the names. Okay, fine. So write the first one, halogenation. Halogenation. Okay. So see, when we have a simple benzene ring, I'll show with this benzene ring. I have a simple benzene ring. Okay, don't write now. Plus we react this with, let us say, Cl2 in the presence of AlCl3. Then the Cl gets attached on the benzene ring on any one of the carbon because all the carbons are same. Now, how this happens here? How this happens, please see. We have here Cl2. And here we have AlCl3. Now, what is very interesting about AlCl3 is, how many bonds are there with Al? Tell me. Aluminium has how many bonds? How many? Can you please repeat that? I could not hear that. Huh? 3, you're saying, right?
Yes.
So it has how many electrons? In total, it has 6 electrons. Now, if it has 6 electrons, that means it is what? It is electron deficient. Correct? Because 8 electrons octet, right? 6 electron, it is less than octet. So it will be deficient. Yes or no, Rifat?
Yes.
Okay. And these chlorines, they have lone pair electrons. This aluminium, it has a vacant p orbital like this. Okay. Now it is vacant p orbital, and here we have extra electron lone pairs. So what happens? The chlorine, it attacks on this aluminium lone pair, which is here, and with its bond also. Okay, with its bond. And what happens? You will get Cl positive plus Al Cl4. This will have a negative charge. Okay. Now, if it is electron rich are known as base. Yes or no? You remember this? Electron rich are bases. Hana?
Yes.
So this AlCl3, it is an acid because it is electron deficient. It is an acid, and both of these, if you are electron rich, you are known as Lewis base. If you are electron deficient, you are known as Lewis acid. I hope you remember this word, Lewis base and acid. And now it is more ingrained in your brain that Lewis acid will be electron deficient. So this is what AlCl3 acts as a Lewis acid. Now we have generated a Cl positive. What we have generated? We have generated a Cl positive. What is a Cl positive? This is the electrophile. Okay, this is the electrophile mechanism. Okay, this is the first step. Now, this Cl negative, the Cl positive is electrophile. That means it loves electron. It wants to attack where the electrons are. Now, where are the electrons? Where are the electrons? The electrons are on the benzene ring, right? So benzene ring, it has pi electron cloud. And we are just doing this reaction in the presence of benzene. Okay, so I'm just showing you what is happening with the benzene ring here. Now, once you have this benzene ring, what is going to happen? Plus Cl positive. Okay. Now, all of these carbon atoms, they will have one hydrogen. They will have one hydrogen here. They will have one hydrogen here. Now, the chlorine atom, it will attack on this, any one of the carbon atoms, and it is going to make H and Cl. And this pi bond will break. Okay, this pi bond will break because this carbon cannot have what? It cannot have 5 bonds. This pi bond will break and it will go to the next carbon atom here. Okay. Now, what will happen after this is done? From here, AlCl4 negative will come and it will attack on this hydrogen. This hydrogen will give its electron here, and further you will be getting a chlorine atom. This electron is gone to this bond, and that is why the pi bond is again regenerated, and you are getting Cl here. Is that clear? Yes or no, please tell me.
Yes.
The 2 steps. This is the important step where you have forming the electrophile. Okay, this is the important step. And whatever Cl, if you are forming, whatever electrophile you are forming, that will get attached on the benzene. Is that clear? Yes or no, please tell me. Yes, refer. Okay. Now the next thing is, if I have haloarene, this Cl, it has lone pair electrons, and as you can see, we have the condition for resonance fulfilled: A double bond B, single bond C, and C with a lone pair electron, right? We have lone pair electrons, multiple lone pair electrons. So one of these lone pair electrons, lone pair electrons, it will move like this and like this, and it will show resonance. And we will be getting a negative charge here. There will be a double bond here, and Cl will get a positive charge because it has lost electron. And there will be bonds like this. And as you can see, this is also neutral, and this molecule also net, it is neutral. Now again, you can see there is one more condition fulfilled for resonance, right? You can see A with a double bond B, A double bond B, single bond C, and a negative charge. Now again, this negative charge will move like this, and this pi electron will move onto this carbon atom, and then you will be getting another resonating structure, which is, just need to focus on the pi bonds here. This is still the same Cl positive. Now this a negative electron, it has gone here, so it will form a new pi bond. This pi bond has gone to this carbon atom, so this will get a negative charge, and this pi bond is as it is. Now again, you can see A double bond B, single bond, C with a negative charge. Again, this negative charge will move, and this pi electron will move on to this carbon atom. Then you will have this Cl positive is as it is. There is no change here. Then we have a pi bond here, we have a pi bond here, and then a negative charge here. Okay. Now you can see there is again A double bond B, single bond C with a negative charge. Now this negative charge will move to this bond, and this pi bond will move to this chlorine. So the chlorine will get the electrons and it will get neutralized. Cl. You get all the electrons here like this, double bond here, double bond here, double bond here. Okay, so these are all the resonating structures of haloarene. If you have anything which is having lone pair electron, it will show these type of resonating structure. What is special about this resonating structure is that none of the structure is real. Okay, none of it is real. The real structure is a mixture of all of these things. Okay, it is a mixture of all of these things. So when you will mix all of these things, you will have a benzene ring. Okay, now we have some atoms here. I will label those atoms, and Rifat, you will turn the mic on now. Okay, we have chlorine 1, then we have this 2, 3, 4, 5, 6. Wait a second. 2 वहां पे नहीं आएगा. 2 को हम यहाँ ले लेते हैं. This is the second atom, 3rd, 4th, 5th, 6th, and 7th atom. Okay, so we have 1, 2, 3, 4, 5 resonating structures. You tell me, in all the resonating structure, in the first resonating structure, what is the bond between 1 and 2, single or double?
Single.
Single. In the second structure, it is single or double? In the third structure?
Double.
In the fourth structure?
Double.
Double, right? So it has, that means the dominant thing here, it will be what? It will be a partial double bond, right? Yes or no?
Yes.
Okay. Now, what about 2 and 3? Does it have single and double mixed, or it is only double or only single?
In the first one, it's double. Otherwise, it's single.
That means it is also going to be
Double.
partial double bond, right?
Yes.
3 and 4? Same,
Partial.
right?
Partial double.
Partial double bond. 4 and 5 also partial double bond?
Yes.
Right? Okay. Just a second. Assalamu alaikum, Aisha. How are you?
Walaikum assalam, sir. I'm fine. What about you?
I'm also good. You're also late, very late. What happened? भूल गए थे
I
आप?
reached home just right now.
अच्छा, कहाँ गए थे आप? घूम रहे थे? दावत
I
थी.
said you right yesterday, so I was at BTS, so like while coming there, we came late actually.
अच्छा, okay. So how many lectures have you missed, Aisha?
What's up?
How many lectures have you missed?
So I have missed actually a lot of lectures, but I was watching that YouTube link.
Pakka?
What's up?
Huh? Are you sure you were watching those?
Yes, the just I missed was that yesterday's one which I watched today. Inshallah.
Okay, fine. Okay. So now we have talked about the bonds Rifat here. Aisha, you will understand this part because this is very similar to what we have done in 11th standard also. Okay. So just try to focus and ask me if you don't understand anything else here. Okay. Fine. Now, Rifat, you tell me in the first atom here, what is the charge in all of the resonating structure? Is it anything? Is it neutral always, or is it having some charge?
Positive.
Positive charge somewhere, right? So it will have a delta positive charge here. Okay. What about the second atom? Is it having any charge in any of the structure, or is it neutral everywhere?
Negative.
Second atom is, sorry,
Has negative
second
charge.
atom.
Oh, second.
Negative.
No, neutral.
Second atom. No charge, na neutral, right?
Yes.
Okay. What about the third one?
It has negative.
It has negative charge in some of the structures, right? So I will give it a negative charge. So it is delta negative. Now, what about the fourth one? Neutral or
Neutral.
Neutral everywhere. Fifth one?
Negative.
So we will give it delta negative. I hope you understand why I'm giving delta negative, because it is having negative charge only in some of the structures, not all these structures, right? Yes or no?
Yes.
Okay. What about the sixth one? Neutral?
Neutral.
Okay. Seventh one?
Delta negative.
Delta negative. Very good. Okay. Now, if I have an electrophile, then it will be preferably attacked by the ortho position. So both of these positions are ortho, right? Ortho to the chlorine, right? So I will get ortho products, and also what I will get the para products. This is the para one, and I will get an attack from both of these sides. I will not get a meta product. You got it? Yes or no? Please tell me.
Yes.
Yes. So we'll write the reaction now. If I have any halogen, let us say we have Cl only, haloarene plus Cl2 in the presence of AlCl3, it will give me two products. The ortho substituted chlorine plus a para substituted chlorine. Okay. This will be major. This will be minor. Okay. And this is minor because when chlorine is going to attack here, it will be repelled by this chlorine atom, and this para position is more free to attack. That is why it will easily attack on the chlorine atom. Okay. So major will be for the para product. Write this down when you're done.
Done.
Okay. Right, next, nitration. Okay. So in all the cases, what you will be getting? Ortho product and para product. So here we have this reaction in which benzene ring, it reacts with HNO3, concentrated HNO3. In the presence of H2SO4, it gives, okay, wait a second. Write a chlorine here. Ortho substituted nitro group, and one nitro group will go to the para position. Okay, so how the mechanism is, I will just write the mechanism in which we are formation of electrophile. Okay, formation of electrophile. So see here we have HNO3. It has a formula like this: nitrogen with a OH group, double bond oxygen, and a dative bond oxygen here. Okay, now I will show this OH like this. Now plus we have H2SO4. Now H2SO4, you know that it will liberate H plus ion, and what it will liberate? It will liberate HSO4 negative. Right? H2SO4 will liberate these two ions. This oxygen here, it has lone pair electrons. It will easily attack this particular H plus ion. Right? It will attack the H plus ion, and what it will form? When OH negative, it attacks on H plus, it will form H2O plus. This NO2 will be, now since it is taking all the electrons, it will be NO2 positive plus HSO4 negative here. HSO4 negative. Now can you see this nitro group? This is nitronium ion here. Okay, this is nitronium ion. Now this NO2, it will attack on the ortho and the para position of haloarene. And you will get what? And you will get ortho substituted nitrobenzene and para substituted nitrobenzene. Okay, again here this will be major and this will be minor. Then yes or no, please tell me. Done. Rifat and Aisha done.
Yes, sir.
Right, next sulfonation. Okay. So इसमें formation of आपके पास. I will not write the product. Okay. Write the reaction like this. Cl plus H2SO4 concentrated. H2SO4. Okay. I will just show you the formation of electrophile. So here we will take two different concentrated H2SO4. It has a formula like this. The sulfur atom, the oxygen like this, and OH group here, and OH group here. Okay. So I will take one H2SO4 like this, and the other H2SO4. There will be many H2SO4 in the solution, and there will be H plus ion very much because we have this acid. Plus there will be HSO4 negative. Right. Now again this OH, it will attack on this H plus ion. It will form HO double bond S double bond S. You will get a positive charge, and then water will leave as it has left here. Okay. So water will leave and you will get HSO3 positive. You will get what? HSO3 positive, in which the positive charge will be on sulfur atom. Positive charge will be on sulfur atom. Okay. You can write it like this also, or you can write it as SO3H, where the positive charge is on sulfur atom. Okay. अब यहाँ पे आपको क्या करना है बस? Draw the benzene ring. Chlorine in the ortho position, what you will write? SO3H, because जो positive charge है जिसपे वही आके attack करेगा. Plus chlorine as it is, and it will attack on the para position, SO3H. समझ में आ रहा है Rifat? Yes or no? Please tell me.
Yes.
Yes. Okay. Aisha, what about you?
Yes,
आप लोग की आवाज आना बंद हो गई. Wait a second, let me plug in my earphone. Am I audible, guys? Hello?
Yes, sir.
Okay. Done with nitration, yes or no, please tell me.
Done.
Done? Done, na? Okay. Right, next. Friedel-Crafts alkylation. It is a name reaction. That is why we'll write some note about it also. Please write the introduction of Friedel-Crafts. Introduction of alkyl group on benzene ring. In the presence of a suitable reagent, a suitable alkylating reagent, it's called Friedel-Crafts alkylation. Okay. So in this, what are the जब benzene में होता है, so in benzene we can use, let me write, alkylating reagent. Okay, so alkylating reagent I can use 3. I can either use RX, any haloalkane, and if this is one is primarily used. Other I can do ROH, alcohols, and also ROR. Okay, so any of these is used, and in the catalyst you will again use a Lewis acid. AlCl3, FeCl3 or something like that, and what you will get, the R group, the alkyl group will attach on the benzene ring. Okay, R group, that is the alkyl group that will attach here. Now, if I am doing the same reaction, I hope you have written the note here. If I'm doing the same reaction with haloalkane, and I will be using, let us say, CH3Br in the presence of FeBr3. Okay, so in this case, what is going to happen? This Br will leave, CH3 will be positive, and you will get two products. Chlorine. What is the alkyl group here? This is the alkyl group. This is the R group. Okay, this is the alkyl group. This CH3 will attach here. Plus, you will get a para product. CH3 will attach here. Okay, so here also this is minor, this is major. Now, if I have something like this, okay, if this is there in the presence of, let us say, FeBr3, now please remember that this is the carbon which is attached to Br, and this is the carbon which will attach to benzene ring. ठीक है, तो आप लोग कैसे बनाइएगा? You'll make the haloarene as it is first with chlorine. ठीक है, उसके बाद you will make a bond and you will attach this carbon. So this carbon has two methyl groups. So this will be the minor product, plus you will get Cl, and the major product will be like this. ठीक है, अगर आप ध्यान से देखिए, in place of Br, what we are attaching? We are attaching this benzene ring at ortho position and para position. You can see that this was the carbon atom which was having the bromine. Okay, so please take care of this. Where is the bromine atom or where is the halogen atom attached? Okay, so this can be also alkyne halide में chlorine भी हो सकता है, iodine भी हो सकता है. Please write this down. Aisha and Rifat, let me know when you are done.
Done.
Aisha, आपने लिख लिया? Yes, Aisha. नहीं लिखा है? चलिए. Right next, Friedel-Crafts acylation. The fifth one, no? So ये fourth था. Fifth one. Friedel-Crafts acylation. The introduction of acyl group in the benzene ring in the presence of suitable acylating reagent is called Friedel-Crafts acylation. ठीक है, so in this we will have a benzene ring. अगर benzene के साथ reaction होता, अब benzene acylating reagent में हमारे पास there are many. You can use acid halide which has a formula R C double bond O X. Okay, and also this is the primary thing that we'll be using. Okay, next you can use anhydride which is having a formula R C double bond O O C double bond O and then again R. Further you can use aldehydes also, R C double bond O H, and others you can use esters, R C double bond O OR. Okay. Now, this part here, this is known as the acyl. So when I use any acylating reagent, what it will do, it will attack on the benzene, ठीक है, और carbon के साथ C double bond O, and it will form this thing here. ठीक है, so this is the carbon atom जिसके साथ benzene bond बना रहा है. Again here यहाँ पे Lewis acid use होगा as a catalyst. Lewis acid. Right here, what is the acyl group? Acyl group is carbon atom is bonded with oxygen and further bonded with R group. This fragment is known as acyl. If the reaction is done with haloarene, we will be using CH3, C double bond O, Cl. As a Lewis acid, we will be using AlCl3. What we will be getting, we'll be getting two products. This will be Cl here as it is, and here we will be getting carbon, double bond O, CH3. Plus we will be getting Cl, carbon, double bond O, CH3. Okay, so this part here, carbon, double bond O, CH3. So acyl. Okay, this is also what? This is also major. This will be minor. Rifat and Aisha done?
Done.
Okay. Okay. So electrophilic substitution is done. जब भी electrophilic substitution की बात होती है, Rifat, so there are two things always you will see it happening. Okay. And if I talk about electrophilic substitution of haloarene, then in each electrophilic substitution there are two parts. एक को बोलते हैं direction. Don't write it now. Direction. और एक होता है reaction. What I will say as reactivity. So direction में it is like either it can have ortho para directing, or it will be what? Meta directing. Right? Now we already know that electrophilic substitution of haloarene, it is what? It is ortho para directing, right? So direction is what? In SE of haloarene, it is ortho para directing. ortho, para, directing in nature. And in reactivity, we talk about how fast does the reaction happen compared to benzene. Okay, compared to benzene. Now, if I look at this particular part, that is the resonance here. In resonance, what do you think? What is happening? Is the ring getting electrons? Yes or no? Tell me. Ring को electrons मिल रहे हैं? हाँ या ना? Electrons का जो movement है वो किस तरफ हो रहा है? Ring की तरफ हो रहा है? Yes or no? Right. So it may seem that we are increasing the electron density, and that is why electrophile will be attacking more easily. Electrophile will be attacking more easily. But that is not the case. Why? Because the haloarenes that we have, all the haloarenes, they are electron withdrawing group with respect to what? With respect to inductive effect. This is my haloarene. So all the haloarenes, they have a tendency to pull electrons through inductive effect. Okay, through what? Through inductive effect from the ring. And that is why this is due to minus I of halogens. And due to this reason, benzene are rather more reactive towards electrophilic substitution reaction than haloarenes. Okay, and now this becomes a question. Okay, also one more thing we can write here, that direction is, or rather orientation or direction, it is, there's a very good line here. There is a very good line. It is controlled by resonance, and this part, that is the reactivity, is controlled by minus I. So write this whole thing, then we will write a few lines. Done. Let me know when you are done with it. Okay.
Done.
Done. Okay. I'll write note. The first point is haloarenes are less reactive towards electrophilic substitution reaction, less reactive towards electrophilic substitution reaction than benzene. And they will ask you why, right? First point you will write. Since, here's the first point, since in haloarenes, minus I of halogen is more powerful than resonance. Now, what happens? Due to which electron density decreases on benzene ring. Electron density decreases on benzene ring, and what we can write, electron density decreases in benzene ring, and the stability of carbocation decreases. Okay, so when we are having this last step, see here when the Cl positive is attacking this 5 meter second, ये arrow ना एक बार आप इसको चेंज कर लीजिए, तो इस arrow में मार्क जो होगा आप इस पर ऐसे रखिए. So it's my mistake. Always from electron source to electron sinks. So here you get a positive charge. Okay, so this carbocation stability it decreases. So हम complete कर लेते हैं, फिर उसके बाद वहां पे चल जाएंगे. Okay, wait a second. Stability of carbocation, what happens? It decreases. Hence, it becomes less reactive than benzene. You will also ask haloarenes are strong electron withdrawing groups but still they give ortho and para products. So the explanation for this is haloarenes are electron withdrawing group due to minus I effect. Due to minus I effect. But since they also show resonance, the electron density is higher at ortho and para position. Ortho and para position. Therefore, they give ortho and para products as reactivity is controlled by inductive effect but orientation is controlled by resonance. Done, guys? Yes or no? Push me. Aisha and Rifat, done?
1 minute.
1 minute, sir. Yes, sir.
Okay. Rifat, done?
Done.
Go to the first reaction of electrophilic substitution. ठीक है? Halogenation की जो second step है ना, उसमें you just make this change. I have shown it like this initially. ठीक है? उसको आप काट दीजिए. Just cut it like this. It is not taking place like this. Rather, it should always be from electron source to electron source, यानी electron rich to electron poor. Okay? So इस पे आप इस तरह से बना लीजिए. Make that change.
Done.
Done. Okay. Right, next. Nucleophilic substitution of haloarene. And here you will write the first statement. Haloarenes do not show SN at room temperature due to the following reasons. Okay. SN at room temperature due to following reasons. Number one, partial double bond at CX due to resonance. Okay, and then you will show it like this. Okay, and so on. So here you will show that there is a partial double bond character due to resonance. Okay, next. Next you will write instability of phenylcation. Okay, so if I have a benzene ring like this, now if we have to do nucleophilic substitution reaction, then this bond should break, right? If this bond breaks, what should be produced? You will be producing a positive charge here. Okay, and this positive charge, it is on which carbon atom? It is surrounded by CH2. Now if this is surrounded by CH2, that is why it is what? It is very unstable. Okay, this is also CH2. All of these carbons are sp2 carbon. This is also sp2 carbon. This is also sp2 carbon, and all of these are electronegative elements, and that is why it will be very unstable. Okay, so this is unstable. Okay, Right, next, third point. Due to repulsion between incoming nucleophile and electron density of benzene ring. Okay, due to the repulsion. Nucleophile is also what? It is negatively charged electron density. These are all benzene ring. This is also what? It is highly electron dense. It is highly electron dense, and that is why they will both repel each other. Right, the fourth point. Right, the fourth point. sp2 hybridization of carbon of CX bond. Okay. Right, due to sp2 hybridization the carbon does not have enough partial positive charge attract the attack of nucleophile. Write these 4 points. लिख लिया आप लोगों ने?
Done.
Yes, done na? Okay. But there are 2 ways in which we can do nucleophilic substitution reaction. Okay, देखिए, right? हाँ, यहाँ पे हमने क्या लिखा? रूम टेम्परेचर पे नहीं होता है ना? Do not throw SN at room temperature, right? Haloarenes becomes reactive towards SN at two conditions. ठीक है, at two condition haloarenes. पहला condition क्या है? Number 1, when you have drastic condition at drastic condition, that means at high temperature and pressure. Second is by placing electron withdrawing group at ortho and para position. By placing electron withdrawing groups at ortho and para positions.
Sir, I have to
हाँ,
join
बताएं।
the next class.
हाँ, तो अभी होंगी ना, 3-4 मिनट होगा, राइट? ये सुनो।
Yes.
हाँ, ठीक है, ये आखिरी है, मैं कुछ और आगे नहीं पढ़ा रहे। तो ये जो केस है इनका ड्रास्टिक कंडीशन, ये तो हो गया, हाई टेम्परेचर एंड प्रेशर। अब इन द नेक्स्ट क्लास वी विल सी व्हाट विल हैपन इफ आई प्लेस ऑर्थो इलेक्ट्रॉन विथड्रॉइंग ग्रुप एट ऑर्थो पोजीशन एंड पैरा पोजीशन। ओके, ठीक है, दैट्स इट फॉर टुडे, विल मीट अगेन ऑन सैटरडे।